Hey there, this is Workbench from Workbench Quagmire. Welcome to day 6 of the Free Code Camp Python certification in 100-ish days. Today we are going to look at Booleans and Conditionals. So let's get started. How do conditional statements and logical operators work? Let's find out. Conditional statements or conditionals let you control the flow of your program based on whether certain conditions are true or false. But before we get into all that, let's go over the basic building blocks of conditional statements, starting with comparison operators. Comparison operators are operators that let you compare two or more values and return a Boolean value. In previous lessons, we learned that Booleans are one of the data types in Python and can only be true or false. Here's a table with the comparison operators in Python. So the double equals is the equals, checks the two values are equal. The exclamation equal is not equal, checks if two values are not equal. Greater than, checks if the value on the left is greater than the value on the right. Less than, checks if the value on the left is less than the value on the right. Greater than or equal, checks if the value on the left is greater than or equal to the value of the right, and less than or equal, checks if the value on the left is less than or equal to the value on the right. Here's some of those expressions that evaluate to true or false. So print greater than 3 greater than 4. Well, that's false. So it will print false. Print 3 less than 4, which is true. It'll print true. Print 3 equals 4, that's false. Print 4 equals 4, that's true, of course. Print 3 is not equal to 4, well, that's true. Print 3 greater than or equal to 4, that's false. And print 3 less than equal to 4, that's true. So those operators can be used in conditionals to compare values and run certain code based on whether the conditionals evaluate to true or false. In Python, the most basic conditional is the if statement. Here's the syntax. If condition, colon, then we go down a line, and here's where spacing becomes important in Python. So this is a block of code. So to show that this pass is part of this if block, it has to be indented by 4 spaces. So in this case, it's if condition pass. So this is the code that would execute if it was true. Pass is also something you can put in your code. Let's say you start to write or you want to placeholder a function, and you write a function, and you just put pass in there so that basically it won't error out, but it's not going to do anything in the code. It's just a placeholder. If statements start with the if word, keyword. So in one of the past lessons, we talked, I think, in strings about keywords. Conditional is an expression that evaluates to true or false, followed by a colon. The body of the if statement constitutes a code block, which is a group of statements that belong together. In Python, the level of indentation is what defines a code block. That's what I was trying to explain. In the example above, the body of the if statement contains a pass statement. When a pass statement is executed, nothing happens. So it's a special keyword that can be used as a placeholder for future code, and it is useful when empty code blocks are not allowed. So just like I was saying, it's, as you're developing your code, sometimes you say, hey, I need to write this function. I'm gonna put it here. I'm gonna define it, but I'm just gonna put pass in here because I don't have the rest of the block of code ready yet. So the code within the body of the if statement runs only when the condition evaluates to true. For example, age equals 18. If age is greater than or equal to 18, print you are an adult. And that would print you are an adult. So notice the indentation before the print. So here we go. Again, this is 2, 3, 4 spaces. While other programming languages use characters like curly braces to define code blocks and just use indentation for readability, in Python, code blocks are determined by indentation. The following code could raise an indentation error, which is Python's way to signal that indentation is required at a certain point of the code. So the same, we have a variable age that's assigned the integer 18 if age is greater than or equal to 18. This time the print is not indented, so you will get an indentation error, expected an indented block after if statement on line 3. So the interpreter gets here and goes, hey, you never finished this if block because this print isn't indented. It's assuming that's a whole different block of code. Though you can use any number of spaces as long as you are consistent to determine each level of indentation, Python style guide recommends 4 spaces. Right, so you could use 3 or 2, but you'll find a lot of code editors will take care of that for you and just insert 4 spaces for you when it needs to. So blocks are also found in loops and functions, which you'll learn more about in future lessons. Going back to the example, if age is anything less than 18, nothing is printed in the terminal. So again, age variable assigned the integer 12. If age is greater than or equal to the integer 18, then print you are an adult. Nothing will show up this time because 12 is not greater than or equal to 18. But if you want to print something if age is less than 18, this is where the else clause comes in. The else clause runs when the if condition is false. Here's the syntax for an if else statement. So, if condition, this thing happens if it's true. Else, if this is condition is false, it runs this line of code. So, it will not run this line of code. It will only run one or the other in this case. Again, our example age, assign the integer 12. If age is greater than or equal to 18, it would print you are an adult. But since 12 is not, this evaluates to false. And so our else clause executes and prints you are not an adult yet. There might be a situation where you want to account for multiple conditions. To do that, Python lets you extend your if statement with the elif or else if keyword. So here's the syntax. If conditional, so if this is true, run this code. If a different condition, run this code. And otherwise, run this code. If both of those are false, then we'll run the else code. In this case, age is assigned the integer 12. If age is greater than or equal to the integer 18, print you are an adult. That is not going to run because this is going to evaluate to false. Elif or else if our variable 12, the integer 12, is greater than or equal to the integer 13, print you are a teenager. That is also false. So it's going to run this last line of code here under the else clause, print you are a child. Seems kind of insulting, but note that you can use as many if elif statements as you want. So age equals 2, and you could do, is it greater or equal to 65? Is it greater or equal to 30? These are all going to evaluate to true or false. And in this case, false, 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 null, also false, also false. And then it's going to say you're a toddler or an infant because you're not greater than or equal to 3, 13, 18, 30, or 65. So now that you understand how comparison operators and conditional statements work in Python, you can start writing programs that make decisions based on logic and input. Whether you're comparing values or branching through multiple conditions, these tools are the foundation of writing flexible, responsive code. Time for our questions. Almost got one wrong last time. Let's see how I do. What do comparison operators do? So, do they perform mathematical calculations with Boolean values? No. Do they convert strings to Boolean values? No. Do they compare two values and return a Boolean value? Yes. Do they create loops and iterations? No. So, there we go. Ooh, one of these, what does this code do thing? So, what will the result of the following code be? What will be the result for the following code? So we have an age variable. We assign it to integer 18. If the integer 12, sorry. If the integer 12 is greater than or equal to 18, well, we know that's false, so it's false. This is not going to run. If the integer 12 is greater than or equal to 13, we also know that's not false. It's not going to run this. So it's going to run this, print you are a child. And so down here, you are an adult will be printed. Nope. You are a teenager will be printed. You are a child will be printed. An error will be printed on the console. I think it's going to be 3. I didn't see anything that would cause an error. Could be wrong, but I didn't see it. Wouldn't be the first time I missed a bug. Won't be the first time or last time you miss a bug either. It's okay. What will the expression the integer 3 greater than or equal to 4 evaluate to? Well, that's false because 3 is not greater than or equal to 4. So true, nope. Syntax error, nope. None, and false. So let's see. All right. We made it. All right. What are truthy and falsy values, and how do Boolean operators and short circuiting work? Not sure I've heard of short circuiting. It's probably something I'm familiar with. I just not called it that. In previous lessons, you learned how to use comparison operators and conditional statements to control the flow of your program. While, which is a flow control keyword, those are very powerful. You will often run into situations where you need to compare multiple values at once, and this can lead to nested conditional statements, for example. Is citizen true? The Boolean value true. Age variable is assigned the integer 25. So if a citizen, so we know that's true, so that's going to evaluate to true, so it's going to run the next thing in the block. It's not going to run this else. And so now we go to if age is greater than or equal to 18, which is true, print you are eligible to vote. So if age had been 16, let's say, this would evaluate to true, this would evaluate to false, and then we would go back down here to our print you're not eligible to vote. So in the above example, will first check if is citizen is true. If so, it will then go to the nested if statement and check if age is greater than or equal to 18. Since age is greater than or equal to 18, the message printed in the terminal will be you are eligible to vote. If citizen is false, then the message printed to the terminal would be you are not eligible to vote. If you are working with more complex conditional statements, then you can use Python's and, or, and not operators. Those are keywords. So when we talk about keywords, you cannot create a variable called and. You cannot create a function called not. That's just not Python's interpreter will check for that sort of stuff and you'll get an error. So of course, while you're running the code, correct? Remember, if we remember back one of our earlier lessons, this is not compiled. So the checking doesn't happen until you get to the code. Before we dive into those operators, let's look at what truthy and falsy values are. In Python, every value has an inherent Boolean value or a built-in sense of whether it should be treated as true or false in a logical context. Many values are considered truthy, that is, they evaluate to true in a logical context. Others are falsy, which means they evaluate to false. So here are a few falsy values. None. If we remember, that's a keyword that represents no value. So if you had age equals none, it wouldn't be an integer. It would just be none. False is falsy, of course. Integer 0 is falsy. It evaluates to false. Float 0.0 evaluates to false. Empty string evaluates to false. Other values like non-zero numbers and non-empty strings are truthy. So if you want to check whether a value is truthy or falsy, you can use the bool function. It explicitly converts a value to its Boolean equivalent and returns true for truthy values and false for falsy values. So here are some examples. Print bool false. Of course, that's going to evaluate to false. Print bool 0. We said that was a falsy value, so that's going to be false. Print an empty quote. So an empty string or whatever. That's false. Print bool true. Of course, that's true. Print bool 1. That's going to be true. Print bool hello. So it's a non-empty string. That's also going to evaluate to true. Now that you understand truthy and falsy values, we could take a look at Boolean operators, which are also known as logical operators or Boolean operators. That's interesting. We look at Boolean operators. So it's a little redundant. These are special operators that allow you to combine multiple expressions to create more complex decision-making logic in your code. There are 3 Boolean operators in Python: and, or, and not. So let's first take a look at and. The and operator takes 2 operands and returns the first operand if it is falsy. Otherwise, it returns the second operand. Both operands must be truthy for an expression to result in a truthy value. So here's our example. Is citizen is assigned the Boolean value true. Age is assigned the integer 25. Print is citizen, which is true, and age. And so age is a non-zero integer, so that evaluates to true. So true and true, 25. So in the above example, the number 25 is printed in the terminal because of the and operator will evaluate the second operand if the first operand is true. And so since this is true, it returns the age. The and operator is known as a short circuit operator. So this is a new concept for me. This is exciting. Short circuit operator. So short circuiting means Python checks the value from left to right and stops as soon as it determines the final result. So you often use and within if statements to check if multiple conditions are met. Here's how we can refactor the earlier example to use the and operator instead of if. So is citizen is true, age is 25. If is citizen, so true, and age is greater than 18. So this is true. So now we go to the other side of the and here. We evaluate this. Age is greater than or equal to 18, which is also true. So we are going to print you are eligible to vote. If you are not a citizen, it would immediately jump to here because one of this first value would be false. So in the above example, is citizen is true and age greater than or equal to 18 evaluates to true. Since both operands of the and operator are truthy, the condition is citizen and age greater than or equal to 18 evaluates to true and prints the call in the block in the if block. And the print call in the if block is executed. Now let's take a look at the or operator. The operator returns the first operand if it's truthy, otherwise it returns the second operand. Or an or expression results in a truthy value if at least one operand is truthy. The or operator is also known as a short circuit operator. Here's an example. So age 19 is employed false. So print age or is employed. So in this case, age is truthy, and so it's going to print 19. It doesn't even have to really evaluate this. The code print 19 because the first operand is true. If you need to check if more than one, if one or more expression is true, then you can use the or operator in a condition like this. Age 19 is student true. If age is less than 18, well, that's false. Or is student, that is true. So we're going to evaluate this line. You're eligible for a student discount. Otherwise, they say you're not eligible. So in this case, age is false, but it is student is true. Since at least one condition is true, the entire or expression evaluates to true, and the discount message in the if block is printed. The last operator we'll look at is the not operator. Sorry about that, which takes a single operand and inverts its Boolean value. It converts truthy values to false or falsy values to true. Unlike previous operators we looked at, not always returns true or false. Here we have a few examples. So print not. So remember, this is false. It's a falsy value. So the opposite of a falsy value would be true. Not hello. This was a truthy value. So it would print false. Another falsy value. So it prints true. A truthy value. So it's false. Is not false is true. And not true is false. So it inverts. It is common to use the sorry about that, the not operator in conditionals to check if something is not true or false, like this. Is admin equals false? If not admin, that will evaluate the true, right? Because we got false and the not inverts it. Print access denied for non-administrators. If that had been false, that evaluated false, it would print welcome administrator. So since is admin is false, then not is admin is not false, which is true. So the message access denied for non-administrators will be printed. Now you can understand truthy falsy values and or not operators and short circuiting works. You can write more flexible, readable conditional logic. Time for our questions. What is the following code output? So age is assigned to the integer 20. Has ticket is assigned to the Boolean value true. If age, so if the integer 20 is greater than the integer 18, which is true, and then has ticket, that's also true, print you can watch the movie. So we are over it or greater than or equal to 18, true and true. Since both are true, we go here. Otherwise, if one of them had been false, say our age had been 12, this would have immediately went to this print can't watch the movie. So you can watch the movie, true. Syntax error, type error. No, I don't think there's any errors. You can't watch the movie. So I'm going to say it's option 1, choice 1. Which of the following is not considered a falsy value in Python? That's falsy. That's falsy. That is not falsy because that's a non-empty string. It is not the Boolean value false. Remember, the quotes mean it's a string. That is falsy. So that tricky question, the non-empty string false is actually true. Truthy. What happens when Python evaluates the expression x or y? It returns x only if both x and y evaluate to true. It returns x. That's not true. It returns x if it evaluates to true and skips evaluating y. That is true. It always evaluates both x and y, regardless of their values. No, it returns false if either x or y is false. That is true. So, nope, I got it wrong. I was right the first time. Let's check my answers now. I finally got one wrong. Day 6, got it wrong. It's terrible, terrible, horrible me. So, all right. Day 6 in the books. Tomorrow, day 7. Build a movie ticket booking calculator. This is a big one. 21 steps. I assume we're going to use some of our, we're going to use strings and numbers and conditionals. So it should be good. We will get through this, I believe, in one day without any issue. And then we'll be back to a theory and then a lab, which I'm curious as to what that is. So thanks for watching. Please like and subscribe. Leave a comment, and I'll see you tomorrow for day 7. See you then.